Today we're going to start our short unit on set notation. From the ways in which you select clothes in your closet to how you organize the apps on your smartphone, the use of sets allows us to have a systematic way to analyze groups of items and information. No matter what the set consists of, the mathematical concept of sets is the building block for many areas of mathematics. A set is a collection of objects made up of specified elements or members. Roster notation is a way to describe a set by listing all the elements in the set. So like down here, set A includes 1, 2, X, Y, and Z. And notice how we put braces around the set. That's part of the notation that we know that it's a set. Two sets are said to be equal if they contain exactly the same elements. The number of elements contained in a finite set, finite meaning it's got a finite amount of items in it, is called the cardinal number or cardinality. The cardinal number is denoted by bars. Okay, it doesn't mean absolute value, but that's what it looks like. Use the roster method to represent S, the set of states in the United States that begin with the letter M, and then find the cardinality. So we're going to list all the states that begin with the letter M, and I would probably have to look at a map to do this if it wasn't already listed out for me. So here they are. There's Maine, Maryland, Massachusetts, Michigan, Minnesota, Mississippi, Missouri, and Montana. And we open and close with braces. The cardinality of this set is just the number of elements. There's 8 of them. So there we go. Sets are equivalent if they have the same cardinal number or the same number of elements. The elements have to be the same to be equal, but to be equivalent, they don't have to be the same. They just have to have the same number. And we write when sets are equivalent with a little squiggle in between. Determine if the given pairs of sets are equal, equivalent, or neither. So the first one, I'm not going to read it for you. You could look at that and you can probably see right away that they're not equal. Let's see what the cardinality of each is. So A has 5 items. B also has 5 items. So they're not equal, but we can say that they are equivalent. X and Y, if you look at these carefully, even though they're listed in a different order, they still contain the same numbers. So we can say that X is equal to Y. Set builder notation is used to describe a set when the members all share certain properties. And it's helpful when representing an infinite set of numbers like the natural numbers. Use set builder notation to represent Y, the set of all given integers. So what we would do is say braces, and set notation looks like this. X such that. Okay, that's what that bar there means for us. X such that. X is an even integer. There's several ways we could write it, but it has to have this braces with that X such that. And that's how we write the notation for an infinite set. The empty set or null set is one that contains no elements, and we write it as a circle with a diagonal line through it. So if you make your zeros with a line through it, you're probably going to want to not do that for this chapter, okay? Determine if the following sets are empty. The set A of negative numbers less than 100. Well, that would be all the negative numbers, wouldn't it? They're all less than 100. So A is not empty. The set B of any state that contains the letter Q in its name. Again, I'd have to look at a map. But there's actually no states that start with a B and contain a Q. So we can say that B is the null set. The universal set is the set of all elements being considered for any particular situation. And it's denoted by U. So you'll see later when we start making Venn diagrams that it's everything that could possibly be in the set is contained in U. The complement of A consists of all the elements in the given universal set that are not contained in A. And it's denoted with a little apostrophe. So for example 5, it says Twitter is a type of online social media where registered users can post tweets that are up to 140 characters long. In the world of Twitter, you can keep up with other users' posts by following them, and in turn, other users can follow you and your tweets. So we're going to let U be X such that X is a registered user on Twitter. So all the people that use Twitter. A is X such that X is a registered user on Twitter and follows you on Twitter, okay? So you could say it's a subset. A is a subset of you. And B, X such that X is a registered user on Twitter and you do not follow X on Twitter. Determine the complements of A and B. So A complement, let's see, A again was X is a registered user. Oh, I gotta say on Twitter. And A said X follows you on Twitter. So we just need the opposite of that. So X does not follow you on Twitter. Okay? And then the complement of B, X is a registered user on Twitter. And B said you do not follow X on Twitter. So the opposite of you don't is that you do. And you follow X on Twitter. So that's the end of this first section. Pretty short.